This paper aims to recover the lost interaction force feedback between an insertable laparoscopic camera and the abdominal wall tissue in a non-invasive manner. The camera was actuated by magnetic fields generated by the actuator to pan, tilt, and translate along the interior abdominal wall. Instead of being integrated onboard the invasive camera, the force sensors have been placed outside of the patient's anatomy on the actuator. The actuator was held and manipulated by a robotic arm, and the force sensors were calibrated by an ATI sensor before they were used in the following experiments. The anchoring test characterized the camera tissue interaction force against the camera actuator distance. The maximum force was 2.3 newtons, and the camera fell at a distance of 68 mm, which is more than 2 times of the average human abdominal wall thickness of 30 mm. During the translation test, the camera began to move when the shear force reached 120 mm, and the resultant camera tissue interaction force was decreased by 35 mm throughout the process. The interaction force was increased from 540 to 570 milliNewtons during the pan motion, and a 15-degree lag between the actuator and the camera was observed. During the tilt test, the camera tilted from 0 degree to 90 degrees, and the interaction force increased from 530 milliNewtons to 630 milliNewtons. Finally, a robotic-assisted force control demonstration was performed based on the force feedback with the idea of shared autonomy. The camera could be freely manipulated with a predefined difference of 0.4 Newton to 1 Newton, and the root mean square error of the control was about 10 milliNewtons. Thanks for your watching.